Slope, which is 8, and it passes through 4 comma negative 1. They're asking us to find the equation of the line. Very good point. Very good question. I was going to start with another one as a preparation for this, but that's a good one. That's a good one. That's fine. Okay, so is this the y-intercept? No. Since it's not the y-intercept, I will be using y minus y1 equals the slope times x minus x1. Ready? So y minus y1 equals the slope times x minus x1. I recommend writing underneath and then copying. So I will write under m, I will write 8. Of course, this is my x1, y1, 4, and negative 1. And now the next step should be easy. After I identify and I wrote underneath, what is y minus minus 1 equal to? Very good, awesome. Then I copy 8, and x minus 4 is x minus 4, and I can't do anything about it. I have to solve for y, which means I will have to distribute 8. So 8x minus 32, and I will have to bring this to the other side. So the equation of the line passing through the point 4 comma negative 1 and having slope 8 is 8x minus 33. Okay, I would like to also look at problem 8, and then you can choose the next one. 6 comma negative 4 and 4 comma negative 2. We're asked to find the equation of this line. So we're given 2 points, and we're asked to find the equation of the line going through them, passing through them. So what do we have to find first? Excellent. So please, you either remember or you identify them as x1, y1, and x2, y2. Can anyone give us y2 minus y1? And negative 2, but minus negative 4 will be positive 4. And 4 minus 6. So the top will be 2, right? And the denominator, it will be negative 2, so the slope is negative 1. So we determined the slope of the line passing to the 2 points, but now I have to determine the equation. Now the question is, is any of these two the y-intercept? If you say yes, then we will be using y equals mx plus b. If you say no, then I have to use the other one, the slope intercept, the slope point form. Correct. We are not given the y-intercept, so we will be determining the equation with y minus y1, the slope x times m times x minus x1. Please write underneath which point would you like us to use. It doesn't matter. If you use point 1 and I use point 2, we'll get the same equation. So which point would we want to use? So the slope is negative 1. Which one?
The first one.
The first one. So then it's 6 and negative 4. I prefer writing them underneath because I'm lazy and I don't want to write it twice. But you can write it. And I don't want to put too many parentheses, basically. That's why I don't want to. So I see that this will be y plus 4. Negative x minus 6. I distribute negative 1. And I subtract 4. So the equation is negative x plus 2. What does this represent? It's the equation of the line passing through the given points. Before we look at the word problem, I would like us to graph a linear equation, of course. Let's say problem 68 on 267. They're all from 267, but I jumped to 68. So we are given 6x minus 9y minus 18 equals 0. We're asked to graph this equation. do not waste your time to solve for y. That would be a total waste of time. We're asked to graph this equation using x and y intercepts. And remember, what is the equation of this line? For which? We have two variables. Which one is 0? Exactly. This is the equation of that, of the x-axis is y equals 0. Altitude 0. What is the equation of this line then? A vertical line. Good. That's all we need to find. In this equation, we will find y when x is 0. All you have to do is cover that term. Move negative 18 or move negative 9y, doesn't matter, and divide by negative 9. When we move negative 18, we have negative 9y equals 18, or y equals? Awesome. Y equals negative 2. Can anyone give us the ordered pair that we will be plotting in a minute? Very good. Awesome. Thank you. The same thing with y equals 0. Just cover it. You have 6x equals 18. 6x equals 18. How much is x? So what is the ordered pair now? 3, 0. That's all we need. I will plot 0, negative 2. And I will plot 3, 0. And that's it. Connect and extend the line. You must write the equation of the line somewhere. Above, below the line, it doesn't matter. 6x minus 9y minus 18 equals 0. Okay. I would like us to look at a word problem to see when we model real-life situations using linear equations. Okay, so I'm going to just zoom in on the graph. Here's the graph for us. This is problem 88 on page 268. 88 on 268. Okay, ready? So we're told this. There is also a bar graph, but I'm not interested. We can take a look at the bar graph as well. So this is the bar graph that they are talking about, in which let's look at it. Okay, so we have life expectancy in the US by year of birth for males and for females. On the horizontal axis, which is the x-axis, we have the birth year. On the y-axis, we have life expectancy. And we have some numbers in here. Okay, 66.6 years, 73.1, 74.3, 79.7, 81.0. Okay, in the year 2010. Also, on the next column, we have this table. We have this graph. So now let's see what they say. The bar graph gives the life expectancy for American men and women born in 6 selected years. In exercises 89 through 90, you will use the data to obtain models for life expectancy and make predictions about how long American men and women will live in the future. So I think 88 is with something else. 88. Yes. Okay. So since I selected life expectancy, we'll stick with that. Okay. So it's problem 89. So let's read. Use the data for males shown in the bar graph at the bottom of the previous column to solve this exercise. Fine. Let X represent the number of birth years after 1960. So how much is X for 1960? Let X represent the number of birth years after 1960. X is 0, correct. And Y represent male life expectancy. Create a scatter plot. Okay. that displays the data as a set of 6 points. We don't have to do that. I'll show you with a graphing calculator if you'd like to do that. Draw a line through the 2 points that show the life expectancy for 1980 and 2000. Use the coordinates of these points to write a linear function that models life expectancy. This is what I want to do. So we're looking at 1980 and the year 2000. So for male of 1980, what do we see the life expectancy is? For 1980, the life expectancy is 70. And then for 2000, the life expectancy is 74.3. So we have 2 ordered pairs. So please make the correction is 89. Problem 89. Okay. So I'm just going to copy the information right now. 1980, 70 years. And in 2000, was 2000 or 2000? Yes, it was 2000, correct. 74.3. We're asked to find a linear function that models the information. And you also told me that 1960 represents x equals 0. So let's come up with 2 ordered pairs that model the data and determine the equation of the line. Can anyone give us 2 ordered pairs from what we have in the problem? 20, 70. Do we all agree with 20, 70? X equals 0 represents 1960. 20 years later is 20. And 70. Can anyone give us the next ordered pair? 40, 74.3. Do we agree with 40, 74.3? Excellent. What do we do next in order to find the equation of the line passing through these 2? Very good. So let's find the slope. 74.3 minus 70 over 40 minus 20. Exactly. Over 20. This is good, but it's not good enough. We need the measurement unit. The measurement unit for the slope is always composed of 2 measurement units. One for the it's a measurement unit of the variable at the top over the measurement unit of the variable from the bottom. What is the measurement unit from the top? What is the measurement unit of this? Very good. What is the measurement unit for the bottom? Exactly, per year. What does that mean? It means that the life expectancy increases each year according to the model by 4.3 divided by 20, which is tiny. It's a few months, right? Or even that, not even that, but it increases. At least it's a positive trend. Good. So we determine the slope. Now, how do I determine the equation of the line? Is any of these the y-intercept? No. So then I have to use y minus y1 equals the slope times x minus x1. I can divide that 4.3 by 20, and I get something small, 0.215. 0.215, and let's use 20 and 70. So y minus 70 equals 0.215, and in parentheses x minus 20. I have to distribute 0.215x minus 4.3 plus, so negative 4.3 and plus 70, because we have to move 70 to the other side. So then y equals 0.215x plus 65.7, is it? So this was an application. This was an application, and we do have a part C. Here's the question. Use the function from part B, the one that we just determined, to project the life expectancy of American men born in 2020, if the trend still continues. So 2020 means X how much? Is there a mistake? Maybe you see something and I don't?
Yeah, I don't know.
But that's okay. Let's do it again. Which part?
The Y minus.
This one here?
No.
From here? So this is y minus y1 equals the slope times x minus x1. And I used 20 for x, 20 for x, and 70 for y. And the slope is 0.215. Is this okay? Better? Is it the next step that was confusing? Or this one?
This one.
Is it better now?
Yeah.
Okay. Anyone else? Other questions, please? Stop if you have questions. So what I did was I distributed x to these two terms. And when you multiply 0.15 by negative 20, you get this. And you move 70 to the other side, and 70 minus 4.3 is 65.7. Is that okay? Are we all caught up? Awesome. So now for 2020, what does that mean? That x is 60. So if the trend continues, we don't know in the future, right? 0.215 multiplied by 60 plus 65.7. If this trend continues, the life expectancy should be, I'm calculating it, 0.215 multiplied by 60 and plus 65.7. And I got 78.6. Questions for me? Questions? Okay, so let's take a look at one last concept before we look at some parallel lines and perpendicular lines and so on and so forth. The last concept for the test is the average rate of change. I would like to determine the average rate of change for any function, and here is an example of a function. And I want to determine the average rate of change for this function between x1 and x2. Can anyone give us the y value here and the y value here? So this point has x1 as x coordinate, and I would like to determine the y coordinate. We've done this at least 3 or 4 times today. Excellent. I had to trigger your memory. Oh, awesome. Thank you. What about this one? Excellent. And now let's imagine that we draw a line. It's called the secant line between these 2 points. The slope of this line will give us the average rate of change. So I'm going to call these points A and B. And I'm going to say that the slope of AB is the average rate of change of the function between A and B, or between x1 and x2. So the average rate of change on the interval x1 comma x2 is the slope of the line AB, which is, and when you're ready, please give it to me, and then we'll choose a problem. Yes, I'm ready. I'm sorry?
Wait, are we giving you the slope?
Yes.
Is it 1, 2, minus 1, 1? Or is it the other way?
We have to use what we have.
So x. F of x 2.
Very good. Awesome.
Minus x 1.
Very good.
X 2 minus.
That's it. So let's choose a problem. I like, for example, 18 on page 279. We are given a function which is the square root of x, and we're given x1 as 9 and x2 as 16. We're asked to find the average rate of change of function f of x between 9 and 16. So we want to find the average rate of change between 9 and 16. And I'm ready when you are. Let's determine the denominator because that's the easiest. Yes, please, Talia, go ahead.
Would the top be 4 minus 3?
Yes, because we have to find f of x1, which is the square root of 9, and we have to find f of x2, which is the square root of 16. Perfect. So I'll write the definition one more time. F of 2 minus f of x2 minus f of x1 over x2 minus x1. And then I will write the square root of 16 minus the square root of 9 divided by 16 minus 9. Very good. So yes, indeed, it's 4 minus 3 at the top. And the denominator is 7. So this is 1 over 7. We don't have to write any measurement unit because we are not told anything about the function. We are not told whether it represents dollars or kilometers, or we have no information. This is just a hypothetical example. And we will end today with one problem. I know I have just 2 minutes. Well, at least we'll start it. That's the last problem that we need to look at. So let's say problem 10 on page 279. We're given we're asked to find a line that passes through -1, 3 and parallel, this is the sign for parallel, to the line whose equation is 3x minus 2y minus 5 equals 0. So let's talk about the scenario here. I am asked to find the equation of this line, and I know 2 things about it. One thing that I know is that somewhere along the line, I'll find this point. I'm also told that it's parallel to a line whose equation is 3x minus 2y minus 5 equals 0. How do I determine the equation of the unknown line? That's our question. What do you think? What should we do? Obviously, I'm immediately thinking of y minus y1 equals the slope times x minus x1 because I have a point that is not the y-intercept. So this is -1 and 3. But what I don't have is the slope. So the question is, how do I determine the slope of this line? Exactly. I have to determine the slope of this line because the slopes will be the same. So how do I determine the slope of this line? What do I have to do in order to determine the slope of this line? I have to solve for y. Solve for y. So 3x minus 2y minus 5 equals 0. I prefer to move 2y to the other side, or reverse it, it doesn't matter. So 3x minus 5 and divide everything by 2. Please do not write the long fraction line and divide by 2. Just write this. I'm just going to take attendance and give you that form to look at. Please do as much as you can as preparation for the test on Monday. Please do as much as you can from this handout. It's a test that I created in my math lab. Your test will not be my math lab copy, but you will have a similar problems, of course. please redo all problems we did in class in preparation for the test.